l'écosystème technologique. Avec nos partenaires, nous réunissons les gens qui innovent afin de créer plus de valeur pour l'industrie des technologies et pour tout le Québec.
Chaque jour, nous posons des gestes qui contribuent à faire émerger des solutions. Nous faisons en sorte que ce qui est aujourd'hui une opportunité devienne demain une réalité.
Good morning, bon matin. So I've been asked to talk this morning about something that's near and dear to my heart. It's my passion. It's what I've been working on for the past few decades now, and that's the clean energy transition. So let me just tell you very quickly a little bit about who we are. So I run a little firm called Dunsky Energy and Climate Advisors. We've been around for 17 years. We have a team of 40 amazing people. We have engineers, economists, MBAs, more eclectic people as well with all sorts of different backgrounds. And fundamentally, what we try to do is accelerate the clean energy transition. That's our mission. We're a very mission-driven firm. And we work with clients across North America to try to make that happen. And we do that in buildings, in renewables, and in mobility. And again, the work that we do is at scale. So that's just really high level on who we are, but that's not why you're here. So let me talk a little bit about the clean energy transition. Again, from my perspective, greatest challenge of modern time, most exciting, most daunting, and ultimately most important, most impactful challenge of modern times. Let me just, before we start on the challenge that we have in front of us, I think it's worth remembering, keeping in mind at least, that this is not the first energy transition that we've gone through. We've done this many times in the past, though maybe not quite to the same scale and not quite the same pace. I'll get back to that later. But if you think historically, Plato, what a great way to start the morning with Plato. Plato, many years ago, wrote this. He wrote, "Our need will be the real creator." And over time, that somehow got translated into this saying that's a little bit better known: necessity is the mother of invention. So we, as a species, have proven this over and over again, that faced with necessity, we invent. We invent solutions to problems that help us continue, that help us progress. It's not been a straight line by any means, but that is a bit of our history. Now, if we go back in time just a little bit, think of whaling. It shows whaling is a great example of the strength and weakness of humanity. We were hunting whales 200 years ago for oil. For whale oil to keep the lights on. And, we did that to excess. We decimated the whale population. We couldn't find enough whales anymore. What did we do? We went and found petroleum, right? Necessity, invention. We found petroleum. If you go even just a couple of decades later, most of the places, most of the ways that we got around was by horses were the primary vehicle for getting us from point A to point B. Horses at one point became a serious problem, especially in big cities. The picture here is a picture of the Easter Day Parade in New York City, circa 1900. And most of the vehicles, pretty much all the vehicles on the road back then, were horse-drawn carriages, horses pulling carriages. The problem was, at the time, that there were starting to be way too many horses, and quite frankly, horse carcasses. And that created a vector for disease. It created a massive public health issue. There was a need, and we came up with the motorized vehicle. There was one motorized vehicle in this picture of the Easter Day Parade in 1900. Fast forward 13 years later, and the same Easter Day Parade on the same street, there was one horse-drawn carriage. Everything else was a motor vehicle. Point being, again, there was a need. We came to the challenge. We invented alternatives, better alternatives at the time, and solved that problem that we had, which at the time was, again, a very big public health issue, especially in the big cities. So we have that history, right? The history continues, of course. It used to be, these are adoption curves. You'll see that same horseless carriage in the early 1900s. You see the curve or the speed at which it was adopted by society, by people. We've invented things over and over again. You see the curves for adoption of television sets and adoption of personal computers. That, by the way, is my first ever personal computer right there, back in the early 80s, a TI-99. And the iPhone is just one of the latest examples. One of the things that you notice in this graph is what used to be adoption curves are increasingly adoption rockets. In other words, we're picking up the pace of change, and we adopt new things much faster today than we ever did in the past, which is a mighty good thing because we now have another challenge. And the challenge that we have is climate. So let me talk to you a little bit, and you guys, I'm sure many of you have, heard all the dour news about climate. And I'm not here to depress people too much, but I do think it's important to understand the scale of the challenge and why this is literally the challenge, not just of this century, not just of this generation, but probably of this species. So to understand the challenge, let's look back in history a little bit. I've got data here from about the last 800,000 years. And the first thing I'm plotting up here is carbon, right? So CO2 parts per million in our atmosphere. If you look very carefully over the past 800,000 years, and this graph, by the way, shows the last 800,000 years up to about 100 years ago, all right? And I'll come back to that. If you look carefully at this graph, you'll notice a couple of things. One is that there have been a lot of variations over time. The other is that we've never exceeded, in all that time, we never exceeded 300 parts per million in the atmosphere. That's carbon. Now, let me show you temperature. This is temperature change over time. You might notice a couple things here too. One is that temperature has changed over time. Every once in a while, there are these cycles that happen to go with carbon. And the other thing, of course, is that there is a pretty strong correlation between temperature and carbon in the atmosphere. So that's the past. And I told you that this goes up to about 100 years ago. And just to put this into perspective, by the way, a little time scale here. Homo sapiens have been around for the last 200,000 years, plus or minus. The last ice age was about 20,000 years ago. So if we just go back to 20,000 years on this scale, much of Europe was covered in ice. What we call today modern civilization started about 10,000 years ago. That's when we stopped moving around so much. We got sedentary. We figured out agriculture. We started creating permanent villages and slowly started building economies. Modern civilization is that little sliver on the right end. Now, I said that the graph stops about 100 years ago. Here's what's happened in the past 100 years to carbon in the atmosphere. It's grown, as you know. It's grown to the point where, as of this past summer, we were at 419 parts per million. So obviously something that this Earth has never seen before, certainly not in the last million odd years. And there the challenge does not stop. So, we're at 419 parts per million. We're starting to see the effects now. For anyone who's paying attention this past summer, wildfires all over the place. If you can see this chart well enough, I'll just tell you what it says. These are California's largest wildfires throughout history. You see the gray parts, 1932 to 1999. That's how much acres of land was lost in California to fires during that 70-year period. The blue part is the acreage that was lost in California in the 20 years, the first 20 years of this century. And then you see how much acreage was lost in 2020 and in 2021, at least through the month of July this past year. So clearly, this is but one example of what happens when you put so much carbon in the atmosphere and temperature tends to follow. That deregulates the climate, and that's why we're talking about climate change today. Again, I promised I'm not here to be a prophet of doom. I want to talk about the challenge that we have in front of us and things that we need to do to actually solve this problem. But just before I do, again, I want to put this into perspective. These 419 parts per million, that's what we have today. If we keep on the trajectory that we are on right now, this is what we're looking at. We're looking at that grow and grow and grow to the point where by the end of this century, we'll be at nearly 1,000 parts per million. I don't need to explain. If you just look at this graph, you think of 1,000,000 years of climate. You think of 1,000,000 years of this planet's existence, of the atmosphere, and you look at what we're talking about and the extent to which and the speed to which we're talking about changing the fundamental composition of the atmosphere that regulates life on Earth. We know this is not sustainable. So we need to change that. We need to bend that curve down. We need to stop this from happening. The way that we need to stop this, or the thing that we need to do to stop this from being the future, is very simple. We need to cut emissions. This is all about burning fossil fuels, and that's what we need to stop doing and stop doing quickly. So I talked about the need before, right? Plato's necessity is the mother of invention. The need here is climate. The number is net zero. The only way we avoid what I just showed is by quickly driving our emissions down to zero, or what we call net zero. That is the race of our time. That is the challenge of our time. Zero. I want everyone to remember that. Keep that in the top of your mind. That's not about to change. That's going to be the same number, the same big goal for humanity for the next year, for the next 10 years, for the next 30 years. Hopefully not beyond that, because by then we have to have achieved it. So let's talk about what it means to get to net zero. In other words, to decarbonize. There are essentially 4 things that we do in society that burn fossil fuels and emit carbon into the atmosphere. These are the 4 things that we need to address. The first is power. The second is heat. The third is getting around, mobility. and the fourth is industry. So let me talk briefly about each of these. I'll start with power, partly because power, electricity, is the piece that we're moving quickest on today. It's the one that frankly is the most hopeful today. Let me take a step back here. For those of you who are in Canada, 83% of our electricity is currently carbon-free, or effectively carbon-free. So we're actually really ahead of the curve in Canada compared to the rest of the world. In the US, it's less than half that's carbon-free, but here over 80% is carbon-free. Nonetheless, our challenge is to get the last 17% out, and that, of course, is just in Canada. Excuse me. The real challenge is worldwide, and that's much bigger. Excuse me. So what does it mean to decarbonize electricity? Let's talk. I'm just going to give you some more hopeful numbers. Let's talk about wind, solar, and storage. They're three of the biggest pieces of the puzzle. In terms of wind power, 10 years ago, worldwide, we had about 180 gigawatts of installed wind capacity. That's about 180,000 megawatts. That's a lot. It certainly is a lot more than when I started in this industry, and we were at somewhere around zero. So we've gotten to 180,000 megawatts by 2010. By last year, we were at 740,000 megawatts, 743 gigawatts. By 2030, current projections, and this is what we need to do, but it's also what we're looking at right now, so that's hopeful, is getting to about 2,700 gigawatts of wind worldwide. So, more than a tenfold increase in 20 years. That's positive. And we need to make that happen. If we think of solar, 10 years ago, we were at a pittance. We were at 41 gigawatts. As of last year, we were at 710 gigawatts. And by 2030, if all goes well, and if we do our work, and if we do it quickly and efficiently, we're going to get to, and we need to get to, 3,800 gigawatts of solar power around the world. That's massive. I'm going to come back in a second and put that into perspective. But before I do, everyone, of course, knows that the wind doesn't always blow, the sun doesn't always shine. And so we need storage. We need an opportunity to take that power, store it when it's produced, to be able to use later when it's needed. Battery storage is it's not the only, but it's one critical component to that. 10 years ago, we were at almost nothing. We were at about 125 gigawatt hours of storage worldwide, battery capacity worldwide. As of last year, we were at about 450 gigawatt hours. And given the progress that we've had on battery technology and the reduction in costs, we're currently looking at something in the range of 8,000 gigawatt hours by 2030. So massive, massive scale improvement on the battery side. That's really hopeful. If we can solve the electricity challenge, and I think that we can, and I think that we will, it's largely going to pass through wind, solar, storage, and a few other trickier technologies. So that's the power side. Let me put that into perspective, by the way. The first hydro dam was built in, I think it was 1878, if I remember correctly. There we go, 1878. In the 132 years of hydro's initial development, the world added 850 gigawatts of hydropower worldwide. That was over the first 130 years. Over the 10 years since then, the world has added more than twice as much wind and solar. So again, putting this into perspective, in 1/10 the time it took us to build out our whole hydropower capacity worldwide, we've built out more than twice as much wind and solar in the past decade alone. That's progress. That's pace. That's the pace of change and the scale of change that we need. And that is happening in electricity. So that's positive. Power is going clean, and it's going clean fast. But that's only a small piece of the pie, because the rest is bigger and tougher. I'm going to go through these really quickly. The rest is heating, mobility, and industry. On the heating side, in Canada right now, about 2/3 of all of our heating needs are supplied how? By burning fossil fuels, mostly natural gas, some heating oil as well. That's how we heat ourselves in this country. 2/3 of us, at least. That's not sustainable. Remember, the ultimate number, the end game, is zero. So if we're talking about zero for heating, what we need to do is move largely, not exclusively, but largely to electricity and heat pumps in particular. And if anyone out there is working on heat pumps or looking into heat pumps is possibly the least sexy and yet most exciting technology out there in the world of energy and decarbonization. Heat pumps are going to almost single-handedly decarbonize the heating sector. On the mobility front, and heat pumps, by the way, are electric. So all of this points to the need for even more clean electricity. On the mobility side, same thing, we need a lot of electricity. We know how we're going to decarbonize light-duty vehicles. They're going electric. We know how we're going to decarbonize most trucking and buses. It's going to be electric, or for the largest long-haul, heaviest duty trucks, might be hydrogen as well. We're not quite sure yet exactly how we're going to decarbonize aviation and shipping. It'll probably be a combination of electricity for the shortest routes and then hydrogen for the medium routes. And if you think of intercontinental flights, there we're really not looking at hydrogen. We're looking at what we call sustainable aviation fuels, which is basically biomass. We're going to have to burn some biomass to allow those planes to do long distance flights without destroying the climate. And on the industrial side, also a lot of electricity is going to be needed. We need the electricity for all the boilers that are out there in industry. We need electricity for all of the low, even mid-grade heat required in industry. And for the toughest pieces, for the highest temperature heat needs, we're going to need to look elsewhere. Probably hydrogen is going to play an important role there. So that's what we're talking about. To decarbonize, to get to zero, these are the solutions. It's that simple when looked at in a simplified way. It's of course a lot more complicated when you get into the nitty-gritty, but fundamentally, this is what we need to do, and we need to do it fast. This is, I'm going to skip over this because a lot of numbers. My firm recently did a very deep dive into Quebec and what Quebec needs to do to achieve net zero by 2050. We looked at literally tens of thousands of different solutions and different end uses, looked at the entire economy of Quebec and every nook and cranny. And ultimately, when you boil it all together, what it comes down to is four things. First, we need to reduce total energy demand by more than a quarter compared to current forecasts. And those forecasts are pretty optimistic as well in terms of energy efficiency. So it's probably going to be more than a quarter. But that's the first thing that we need to do. We need to get demand under control. And how do you do that? Through a lot of energy efficiency, a lot more energy efficiency than we've ever had before. And also by starting to reduce the actual needs that we're asking energy to supply. So in other words, shorter trips, using public transit more, Better urban planning is essential, etc. So that's on the demand side. The second thing that we need to do, of course, is replace fossil fuel use, and do so how? By building out more renewables and then replacing the fossil fuel using equipment with electric equipment to a large degree. You see the scale of change here, and one thing that you might notice is that the effort that we need to put into the demand side of the equation, into getting more energy efficient and reducing energy needs, is just as important as the colossal effort that we're going to need to put into building out more renewable supply. Those two pieces of the puzzle are by far and away the most important ones. And if you're wondering what to focus on, that's it. Think energy efficiency, think renewable supply. That's how we're going to solve a lot of this problem. The last thing we need to do, by the way, is sequester the remaining fossil fuel use that we might not be able to get out of the system. And that's a whole other conversation. I'll leave that for another day. So clean power, along with a lot of energy efficiency, unlocks the rest of the puzzle. That's how we get there. One other note, to do this, we're going to need a lot of money. If we look currently, we're spending about $500 billion a year on the clean energy transition. That's up from almost zero when I started my career. In fact, up from zero barely 20 years ago. I've been doing this for 30 years myself. But we're spending about $500 billion a year right now. That's not nearly enough. If you look at what the International Energy Agency just told us, and I think this is one of the most consequential reports that's ever been put out there on this issue, they essentially said two things. We need about $5 trillion a year by 2030 to achieve net zero. 5 trillion, so that's 10 times more than we're putting in right now on an annual basis. What's that for? That's to help us get a lot more efficient and to help build out all of that renewable supply. The other thing they said is that we have to immediately stop investments in new coal, oil, or gas infrastructure. And so all of that money, we need to be redirected toward the clean energy transition. That's a huge call to action. It's an unprecedented call to action, especially coming from the IEA, which was actually formed to protect global oil supplies in 1974. But it's an important one. It's a critical one. It's one that we're going to have to follow. I'm running out of time. I'm going to skip the mention of Mark Carney on the capital side, other than to say that he is doing extraordinary work pulling together the capital and has so far gotten something just over about $50 trillion of capital holders committed to decarbonizing, committed to using their capital to decarbonize over time. I said before that necessity is the mother of invention, or at least that Plato said that. This is the necessity, getting to zero. We've done this before, we've done transitions before, but we've never done anything this big, this consequential, this daunting, and ultimately this impactful. We've never done this before. This is the challenge of a lifetime. If you are asking yourself what to do with your talents, where to put your energy, your effort, your talents, your strengths, your knowledge, put it into this. That's my call to action. I've been doing that all my career, and we need so many more people to just go head down, devote our careers, devote our knowledge and experience to this battle, to this fight, to this challenge, because it is ultimately the greatest challenge of our lifetimes. So thank you with that, and I guess that's it. I wish you well.